2020 National Electrical Code, or NEC, requires that all nuts, screws, and connectors be tightened securely, ensuring proper electrical connections and preventing arcing or overheating as detailed in NEC Section 110.14. Snap-in, no-lock nut conduit connectors rely on friction to secure the conduit. They do not have a lock nut to tighten, which raises concerns about their compliance with the NEC. Snap-in, no-lock nut connectors rely on the contact between the conduit and the connector for grounding. This contact is affected by factors like panel wall thickness, the diameter of the knockout, and the tightness of the fitting. Variations in these factors can compromise grounding, potentially creating electrical hazards. If an accident or fire occurs due to a loose snap and conduit connector, it could lead to significant liability for the installer, contractor, or manufacturer. This is because the lack of proper tightening could be interpreted as a code violation and negligence. To ensure code compliance and reduce liability, it is recommended to use conduit connectors with lock nuts. These connectors can be tightened securely, providing reliable electrical connections and grounding. If snap-in, no lock nut connectors are used, the following precautions should be taken. Firstly, ensure that the connectors are installed by a qualified electrician. Secondly, verify that the grounding is secure. Thirdly, regularly inspect the connectors for tightness and any signs of damage. Snap-in, no-lock nut conduit connectors raise concerns about code compliance, grounding, and lawsuit potential. While they may be convenient to use, it is safer and more advisable to opt for connectors with lock nuts to ensure proper electrical safety. A secure electrical connection, as mandated by the NEC, is critical for preventing a multitude of electrical problems ranging from minor inefficiencies to significant safety hazards. Arcing, which can occur when connections are loose or improperly tightened, can generate excessive heat, potentially leading to fires. Overheating, another consequence of poor connections, can degrade insulation, damage equipment, and also increase the risk of fire. Therefore, adhering to the NEC requirement for secure connections is not merely a matter of compliance but a fundamental aspect of ensuring electrical safety and reliability. The design of snap-in, no-lock nut conduit connectors inherently raises concerns about their ability to maintain a consistently secure connection over time. Unlike traditional connectors that use lock nuts to apply a compressive force, these snap-in connectors rely solely on friction. This reliance on friction introduces several potential points of failure. Temperature fluctuations, vibration, and the natural settling of materials can all reduce the frictional force, leading to a loosening of the connection. Furthermore, the absence of a lock nut makes it difficult to verify the tightness of the connection visually, increasing the risk that a substandard connection will go unnoticed. Grounding is a critical safety measure in electrical systems, providing a low-resistance path for fault currents to return to the source, thereby tripping circuit breakers or fuses and preventing electrical shock hazards. The effectiveness of grounding depends on the integrity of the electrical connections throughout the grounding path. When snap-in, no lock nut connectors are used, the grounding path relies on the contact between the conduit and the connector. This contact can be compromised by several factors. Firstly, variations in panel wall thickness can affect the amount of contact area between the connector and the panel. Secondly, the diameter of the knockout, if not precisely matched to the connector, can also reduce the contact area. Thirdly, even the initial tightness of the fitting can be influenced by installation technique and manufacturing tolerances. Over time, corrosion, oxidation, and mechanical stress can further degrade this contact, increasing the resistance of the grounding path and potentially rendering it ineffective. Given the potential for these connectors to compromise grounding, it is essential to take extra precautions when using them. Proper grounding verification techniques, such as impedance testing, are crucial to ensure that the grounding path remains effective. In the event of an electrical accident or fire, the issue of liability can become a complex legal matter. If it is determined that a loose snap and conduit connector contributed to the incident, multiple parties could potentially be held liable. The installer, who is responsible for ensuring that the electrical system is installed according to code, could be held liable for negligence if the connectors were not properly installed or inspected. The contractor, who oversees the installation and is responsible for the overall quality of the work, could also be held liable for failing to ensure that the installation met code requirements. The manufacturer of the connectors could potentially be held liable if the connectors are found to be defective or if they failed to provide adequate warnings about the limitations of the connectors. The legal consequences of an electrical accident or fire can be severe, including substantial financial damages, reputational harm, and even criminal charges. Therefore, it is essential to take all reasonable precautions to prevent such incidents from occurring. The use of conduit connectors with lock nuts offers a more secure and reliable alternative to snap-in, no-lock nut connectors. Lock nuts provide a mechanical means of tightening the connection, ensuring a consistent and secure contact between the conduit and the enclosure. This mechanical tightening also makes it easier to verify the tightness of the connection visually. Furthermore, lock nuts are less susceptible to loosening over time due to vibration, temperature fluctuations, or material settling. For these reasons, the use of conduit connectors with lock nuts is generally recommended, particularly in critical applications where safety and reliability are paramount. When snap-in, no lock nut connectors are used, it is essential to follow specific precautions to minimize the risks associated with these connectors. Firstly, it is imperative that the connectors are installed by a qualified electrician who is familiar with the limitations of these connectors and understands the proper installation techniques. Secondly, it is crucial to verify that the grounding is secure using appropriate testing methods. This verification should be performed both during the initial installation and periodically thereafter. Thirdly, regular inspections should be conducted to check for any signs of loosening, damage, or corrosion. These inspections should be documented, and any issues should be addressed promptly. In conclusion, while snap-in, no-lock nut conduit connectors may offer convenience in certain applications, they also raise significant concerns about code compliance, grounding, and liability. These concerns stem from the connector's reliance on friction for securing the connection, which makes them susceptible to loosening over time. The lack of a lock nut also makes it difficult to verify the tightness of the connection visually. Furthermore, the grounding path provided by these connectors can be compromised by variations in panel wall thickness, knockout diameter, and installation technique. Given these concerns, it is generally safer and more advisable to opt for connectors with lock nuts, which provide a more secure and reliable connection. When snap-in, no lock nut connectors are used, it is essential to follow specific precautions to mitigate the risks associated with these connectors. Firstly, ensure proper installation by a qualified electrician. Secondly, verify the grounding thoroughly. Thirdly, conduct regular inspections. By taking these precautions, it is possible to minimize the risks associated with snap-in, no-lock nut conduit connectors and ensure a safer electrical installation. Electrical codes and standards such as the NEC are continuously updated to reflect advancements in technology and to address emerging safety concerns. It is important for electrical professionals to stay informed about the latest code requirements and to adopt best practices for electrical safety. This includes understanding the limitations of different types of connectors and selecting the appropriate connector for each application. By prioritizing safety and adhering to code requirements, electrical professionals can help to prevent electrical accidents and protect the public from harm. Remember that electrical work can be inherently dangerous and should only be performed by qualified professionals. If you are not qualified to perform electrical work, it is essential to hire a licensed electrician to ensure that the work is done safely and correctly. The information provided here is intended for general educational purposes only and should not be considered a substitute for professional electrical advice. If you have any specific questions or concerns about electrical safety, it is always best to consult with a qualified electrician. The NEC provides comprehensive guidelines for electrical installations, covering a wide range of topics including wiring methods, grounding, overcurrent protection, and equipment installation. The NEC is updated every 3 years, and it is important for electrical professionals to stay current with the latest edition. The NEC is not a law itself, but it is often adopted by state and local jurisdictions as the basis for their electrical codes. This means that compliance with the NEC is often legally required. Failure to comply with electrical codes can result in fines, penalties, and even criminal charges in some cases. Therefore, it is essential for electrical professionals to understand and adhere to the NEC requirement. The NEC also provides guidance on the selection and installation of electrical equipment, including conduit connectors. The NEC specifies the types of connectors that are permitted for use in different applications, as well as the requirements for their installation. The NEC also addresses the grounding requirements for electrical systems, including the requirements for grounding conductors, grounding electrodes, and bonding. The NEC requires that all electrical equipment be properly grounded to protect against electrical shock hazards. The NEC also provides guidance on the selection and installation of overcurrent protection devices, such as circuit breakers and fuses. Overcurrent protection devices are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the size and type of overcurrent protection devices that are required for different circuits. The NEC also addresses the requirements for electrical inspections. The electrical inspections are conducted to ensure that electrical installations are in compliance with the NEC. Electrical inspections are typically performed by state or local electrical inspectors. In addition to the NEC, there are other standards and codes that may apply to electrical installations, such as the National Electrical Safety Code (NESC) and the International Building Code (IBC). The NESC covers the requirements for electrical power and communication lines, while the IBC covers the requirements for building construction. It is important for electrical professionals to be familiar with all of the applicable codes and standards for their area. The use of appropriate tools and equipment is essential for performing electrical work safely and effectively. This includes using properly insulated tools, wearing appropriate personal protective equipment (PPE), and following safe work practices. Electrical work should never be performed while standing in water or on a wet surface. Power should always be disconnected before working on electrical circuits. It is also important to use a voltage tester to verify that the power is off before touching any electrical wires or component. Electrical hazards can be deadly, so it is essential to take all necessary precautions to protect yourself and others. By following safe work practices and adhering to code requirements, electrical professionals can help to prevent electrical accidents and ensure a safe electrical environment. Continuous learning and professional development are crucial for electrical professionals to stay up to date with the latest technologies, codes, and standards. This includes attending training courses, reading industry publications, and participating in professional organizations. By investing in their education and professional development, electrical professionals can enhance their skills and knowledge and provide the best possible service to their clients. The electrical industry is constantly evolving, so it is important to stay informed about the latest trends and developments. This includes new technologies such as smart grid and renewable energy systems, as well as changes to codes and standards. By staying up to date with the latest trends, electrical professionals can position themselves for success in the future. Ethical conduct is also essential for electrical professionals. This includes being honest and transparent in their dealings with clients, providing competent and professional service, and adhering to the highest ethical standards. By maintaining a strong ethical compass, electrical professionals can build trust with their clients and earn a reputation for integrity. In conclusion, electrical safety is a shared responsibility that requires the commitment of everyone involved in the electrical industry. By following safe work practices, adhering to code requirements, and investing in continuous learning and professional development, electrical professionals can help to prevent electrical accidents and create a safer electrical environment for all. The information provided here is not exhaustive and should not be considered a substitute for professional electrical advice. If you have any specific questions or concerns about electrical safety, it is always best to consult with a qualified electrician.